Hello students, I Ms. Pooja Kalandi, Assistant Professor from ISM RAC. Welcome you back to this video lecture on linear programming problems. Today we will be seeing very important LPP using simplex method. Before we move on to the problem, I would like to clear some concepts regarding the simplex method. So basically simplex method is one of the method which is used to solve the linear programming problem. As you've already seen, transportation problem is also one LPP, then you've also seen assignment problem. Similarly, this LPPs are being solved by a basic method which is simplex method, and based on the simplex method there are other problems like we have big M method, we have two-phase method, and we have the dual simplex method. So let's see what is basically involved in the simplex method. There is one concept called as the slack variable, which is a non-negative quantity which is being added to a constraint to convert it to an inequality to equality. That is, if you have an equality which is less than equal to, as you can see here, then a slack variable will be added. Now, second concept comes the surplus variable is a non-negative quantity which is subtracted from the constraint for a greater than equal to constraint. So, surplus variable will be subtracted in case of the greater than equal to constraint. Now, what are the steps to solve this simplex method? So, just you have to remember the two variables, that is this slack variable and the surplus variable. Now, first step in simplex method is to convert the given equation to standard form of LPP. If it is less than equal to constraint, okay. So if it is greater than equal to constraint, then you will be adding the slack variable. If it is sorry, if it is less than equal to constraint, you will be adding the slack variable, and if it is greater than equal to constraint, you will be subtracting the surplus variable. Now also we have to add the variables to the objective functions also. Now you need to calculate the initial simplex table. This initial simplex table will be giving you the coefficients of the basic variable. You'll be writing the basic variables, and then you'll be writing the coefficients of the objective functions. Okay. So after this, we'll be calculating the values of Zj. Zj uses a formula of, it is a product of CBI into AIJ. This will be summation for the values. How many values will be there? That much summation will be done, and the product of sums will be, the sums of products will be calculated. After this, you need to calculate the values of Cj minus Zj. After calculating the values of Cj minus Zj, you need to examine the sign of Cj minus Zj, because we need to check the optimality condition. So for testing the optimality condition for maximization problem, Cj minus Zj should be less than equal to 0. Very important, you have to note this condition very properly. And for minimization problem, Cj minus Zj should be always greater than equal to 0. So this is the important thing which we need to remember or to understand in case of the simplex method. After this, we are going to compute the minimum ratio. Then we'll be finding out the key column, key row, and the key element. We'll be finding out which is the entering variable, which is the leaving variable. And then we'll be calculating the values of x1 and x2 for the next iteration. And we'll continue this value till we have the last equation based on the optimality condition. So as we know that this will be the optimality condition. So whenever we reach all the values of Cj minus Zj less than equal to 0 in maximization problem, we'll stop up there. And in case of minimization problem, when we'll have all Cj minus Zj value greater than equal to 0, then we'll stop our simplex method. So I hope these are the basic steps. I'll be sharing this PDF with you, so you will understand what are the steps involved. Now let's see what is the problem for today on simplex method. So I'll be covering today maximization problem. So you have to remember the constraint in maximization problem is, so this is the constraint where Cj minus Zj will be less than equal to 0. Okay, so we'll see the given problem is objective function given is z equal to 12x1 plus 16x2, and subject to constraint, these are the two constraints, 10x1 plus 20x2 is less than equal to 120, and 8x1 plus 8x2 is less than equal to 80, and x1 comma x2 is greater than equal to 0. Now first thing, as we know, is we have already seen in the graphical method also, you need to convert the equation into the standard form of equality. So what we need to do is, first we'll if you see here, this is a maximization problem, and you know that if it is a less than equal to constraint, we will be adding the slack variable. So in this both there is less than equal to constraint, so we'll be adding the slack variable. If it would have been a greater than equal to constraint, we would have subtracted the surplus variable. Okay, so we have added the slack variable and we have converted the given equation into the standard form of LPP. So, and this slack variables are also added into the objective function, that is z is equal to 12x1 plus 16x2 plus 0s1 plus 0s2. Now we need to construct the initial simplex table. So you just have to pay attention while I'm telling you the simplex table. So see, we need to see first, jot down the basic variables. Now you know that we have the four variables: x1, x2, s1 and s2 in objective function. So we have written here x1, x2, s1, s2. After this, we need to write the coefficients of the objective function. So if you see here, it is 12, 16, 0 and 0. So I have written here 12, 16, 0 and 0. And here we will writing the basic variable. Basic variable means which variables we have been derived. If you see, these are s1 and s2. So in this case, if you see their coefficient, it is 0. So I have written here 0, 0. After this, here we need to write the values of the constraints. So if you see the first constraint, what are the coefficients of the first constraint? 10, 20, 1 for S1 and 0 for S2. So this will become 10, 20, 1, 0. And what is the final value? Equals to 120. So that will be writing in the solution column, that is 120. Now if you see for S2, what are the values of X1? So in this case, 8x1. Coefficient for x1 is 8, x2 is 8, s2 is 1, and for s1 is 0. We'll be writing here 8, 8, 0, 1, and 80. Okay, so after this, what you need to do is, again, step number 3, you need to calculate the values of zj. Now, zj is nothing but, first you need to take the product of CBI into the x1 value, that is 0 into 10 plus 0 into 8, that is going to be 0. Again, for next x2 row or x2 column, 0 into 20 plus 0 into 8, that is again equal to 0. Similarly, 0 into 1 plus 0 into 0, that is again 0. 0 into 0 plus 0 into 1, that is again 0. So by default, you'll be getting all the values as 0 for the first simplex table. Now you need to calculate the values of Cj minus Zj. So this is the Cj value and this is the Zj value. So 12 minus 0, so 12 minus 0 will be 12, 16 minus 0 will be 16, 0 minus 0 will be 0, again 0 minus 0 will be 0. Now you need to examine the values of Cj minus Zj for the optimality condition. So we know that for this maximization problem, all the Cj minus Zj should be less than equal to 0. But if you see here, these are not less than equal to 0. These two are 0, but these two are greater than equal to 0. So our optimal solution is not reached. So we need to go to the next iteration. So before going on to the next iteration, what you need to do is you need to calculate the key column, the key row, and the key element. So how will we do that? We have to check the most positive value from the Cj minus Zj values. So if you see here, these are 0 value, but in of 12 and 16, the most positive value you have here is 16. So this column will become the key column. And now you need to calculate the ratio. Ratio is calculated as solution divided by the value which is present in column x2. So 120 by 20 equals to 6, and again 80 by 8 equals to 10. Now here you need to check the minimum positive value, which is the least positive value in this case. So the least positive value here is 6, so this becomes the key row. Once again, I'm telling you, in this case, you have to examine the values of Cj minus Zj. These are, since these are greater than 0, we will be choosing the most positive element to find the key column, and we'll be choosing here the least positive element to find the key row. The intersection will give you the key element, okay, or the pivot element. So after this, you have got the initial simplex table. Now we need to go to iteration number 1. The iteration table will be same table, but only change here is, here since this has become the key column, the variable here is x2. So this x2 becomes the entering variable. But in case of s1, this s1 will become the leaving variable. So this is entering variable x2, leaving variable s1. Therefore, s1 will be substituted by x2. So if you see in iteration 1, you can see that S1 is being substituted by X2. Now we have written the same, other things are almost same, nothing changed. 12, 16, 0, 0 coefficients of the variables. Now X2 coefficient in the objective function is 16, so we have written here 16. You can just check it out here. If you see here, this is 16 coefficient of X2. So now what you have to do is, in this case, here in the key element or the key pivot, you have to bring here 1, and here you have to bring 0. So you can use row transformation values first. In order to find this first row, For the new table, that is iteration 1, you need to divide this entire row by the key element. Means you need to divide this whole row by 20. So it will be 10 by 20, 20 by 20, 1 by 20, 0 by 20, and 120 by 20. So this will give you the following values as I've written it: 10 by 20, 1 by 2, 20 by 21, 1 by 20, 0 by 20, 0, 120 by 26. So you've got the first row. Now in order to find the second row, you have, as I told you, you have to bring here 0. Okay, you have to bring 0 at this place. So what we can do is, we can, if we subtract the value, this is 1. Okay, you have to subtract this 8 with this 1, but if it is only 1 here, so what if we multiply it with 8? So what will happen? 8 minus 8 will become 0. So we can use the formula as new R2, new row 2, new R2 equals to old R2, this is old R2 minus 8 into new R1. That is, since you know that it is 1 here, okay, since it is 1 here, if we have 8 into 1, that is 8, so 8 minus 8 will give you 0. So in this case, you will have the 0 value. So we have to remember this transformation. New R2 equals to old R2 minus 8 into new R1. Okay, so after we do this, we will be getting these values. Okay, 4, 0, minus 2 by 5, 1, 32, okay, and 8. So I have just shown you here one example. You can see here. Now the old R2 value is 16. In case of X1, I'm calculating for the X1 value. So if you see, the old R2 value is 16 into 1 by 2. So this is going to be 16 into 1 by 2 plus 0 into 4, that will give you 8, or you can use this formula. Okay, so if you see, old R2 here is 8. Okay, old R2 is 8 minus 8 into new R1. What is the new R1 value here? Okay, so the new R1 value, how much we have here is, in this case is, new R1 is 1 by 2. Okay, so what you'll be getting here, you can see here, this will be 16 into 1 by 2 plus 0 into 4, that equals to 8. Okay, so similarly, I've not calculated some steps here. So here, just you can just remember this formula and you can do the calculation. Okay, so old R2 minus 8 into new R1. If I'll just show you for this, you can see here, this is 8 here. So we can write here 8 minus 8 into new R1 value. Now new R1 value here, it is 1. Okay, so we have written it 1. So if you see the step first one, old R1 value is 8. Okay, so don't consider this formula, just consider the old R2 value here is 8 minus 8 into new R1. So what is the new R1 value here? 1 by 2. So 8 into 1 by 2 will be 4. So 8 minus 4 will be 4. So you'll be getting this value as 4. In the similar manner, you'll be getting the remaining values. Okay, so after this, again you need to calculate the values of Zj. Now Zj will be how, I'll tell you, 16 into 1 by 2, that is 8, plus 0 into 4, that is 0. So 0 plus 8 will be 8. 16 into 1, that is 16, plus 0 into 0, that is 16. So similarly, we'll be getting the remaining values. Now we'll be calculating Cj minus Zj. 12 minus 4 is 8. 16 minus 0 is 16. 0 minus minus 2 by 5, that will be plus 2 by 5. And okay, sorry, 0 minus 4 by 5 will be minus 4 by 5, and 0 minus 0 will be 0. Now again you have to examine the values of Cj minus Zj, and you can see here, these are negative. Optimality condition for maximization problem is all Cj minus Zj should be less than equal to 0. Now these three are less values, but there is only one positive value existing. So you have to select this as the key column. Now again you have to calculate the ratio after you get this key column. So what you have to do is, you have to divide this as, this is, you can see your solution is 6 here. 6 divided by 1 by 2 will give you 12, and 32 divided by 4 will be 8. So in this, the least positive value is 8. So this becomes the key row, this becomes the key column, and this becomes the key element. Now in similar manner, you'll be calculating the new values. Now here, in order to make this one, you'll be dividing this entire row by 4. So 4 by 4, 1, 0 by 4, minus 2 by 5 divided by 4, 1 by 4, 32 by 4, and in this way you'll be getting the values here. Okay, so 1, 0, minus 1 by 10, 1 by 4, and 8. Now in order to bring here, 0 at this place, what you can do is, you have to use new R1. So this will be new R1. Okay, so new R1 will be equal to old R2, or new R1 is equal to old R2 minus 1 by 2 into new R1. Okay, so because here it is 1 by 2, you need to bring it here 0. So we'll be using that formula, and on that basis you'll be calculating this values. Okay, now again, if you see here in this case, here x1 is the entering variable and x2 is the leaving variable. So this is being substituted here, x2 x1, x2 coefficient 16, x1 coefficient 12. Now after you have calculated this value, again you'll be calculating zj and again cj minus zj. Now if you see here, all the values of cj minus zj are negative, that is less than equal to 0. Hence our maximization problem is solved with the values x2 is 2 in the solution column, x1 is equal to 8, and the z max we have got it as 128. So in order to sum up the steps of simplex method is, first you have to bring all the equations to standard form, then you need to construct the initial simplex table. After that you have to check the optimality condition. For maximization problem, all cj minus zj should be less than equal to 0. For minimization problem, all the values should be greater than equal to 0. So just if you see, if this would have been a minimization problem, you should have minus sign here, minus minus 0 0. So then you will be converting it into the minimization, means what, you will be making all the values as positive. Okay, so that will be the case in case of the minimization problem. Okay, so this was the example regarding the simplex method where we have seen the maximization problem. So I hope you are clear with the video. In order to make yourself more clear with the concepts, try to solve the same problem which I have given on the LPP. I'll be sharing the notes also with you. So try this problem, and if any problem or queries, please let me know. Thank you for watching.